All right, let's look at standard form. For week 1, we are going to study standard forms. So we have a prerequisite knowledge. You have to recall that in indices, remember from indices, when we say 10 times 10, it means 10 raised to the power 2, right? Okay, so 10 times 10, we have 2 digits here for 10, so that's 2 numbers, so 10 raised to the power 2. So that means 10 on its own is just same thing as 10 raised to the power 1. 1 over 10 is the same thing as 10 raised to the power minus 1. 1 over 10 is equals to 10 raised to the power minus 1. And then 1 over 100 is equals to 1 over 10 raised to the power 2, or 10 raised to the power minus 2. When we divide a number like say 5 divided by 100, for example, it is equals to 5 times 1 over 100. So when you are dividing by 100, it is the same thing as multiplying by 1 over 100. Okay, so 5 divided by, let's say 8 divided by 100 will be 8 times 1 over 100, or 8 divided by 1,000 will be equals to 8 times 1 over 1,000. So dividing by a number is the same thing as multiplying by the inverse of that number. That means 1 all over that number. Okay, just like if you divide your age by 2, the same thing as multiplying your age by half. All right, so get that. Okay, so let's jump right into it. What is the definition of standard form? What do we mean by standard form? When we say writing a number in standard form, another word name for standard form is scientific notation. So scientists all over the world agree on a standard form. So it's a standard way of expressing numbers in mathematics or science. Okay, so standard form is a standard way we express numbers or values, numerical values in mathematics or science. Now the standard form of numbers is of this form: a times 10 to the power of n, where a can be any number between 1 and 10, 1 inclusive. So from 1, 1.5, 2, 3, but not up to 10. So we'll stop at 9.999. Okay. All right. So let's look at numbers greater than 1. Anytime we move the decimal point in a number to the left, we are making that number smaller by 10. Okay. So to maintain the original number, we have to multiply by 10. Anytime you move the decimal point in a number to the left, you are making the number smaller by 10. So we maintain the original number by multiplying by 10. Remember, when you multiply a number, it gets bigger. All right. For example, look at this number, 1,000. 1,000. No, 1,000 can be written as 1,000.0. Okay. When you don't have a decimal point in a number, just take it like that. 0.0. Just add 0.0. All right. So a typical example is 1,000. Let's look at number 1,000. 1,000 can be written as 1,000.0. Okay. Just 200 can be written as 200.0. 560 can be written as 560.0. So if we move this number, the decimal point to the left, it becomes 100.0. So we have to compensate the original number by multiplying by 10. The number of times we moved it once, multiply by 10. So 1,000.0 is something as 100.0 times 10. If we move it again another time, becomes 10.0. So 10.0 is times 10 to the power 2.